Hello, hello, Total Developers back again with another video, and today we will be going over the origins of the Fibonacci search algorithm, as well as a little bit of a review. So let's get started. First things first is that what is the Fibonacci search, right? So the Fibonacci search is a search algorithm that utilizes the Fibonacci numbers to divide the search range. It's particularly effective for sorted arrays, and unlike binary search, Fibonacci search examines locations where indices are Fibonacci numbers. Cool. So let's go over the historical background, right? And we can start at the origins. So the Fibonacci search is named after the Fibonacci sequence, and it was introduced by Leonardo of Pisa, Fibonacci, in 1202, right? And the sequence is characterized by the fact that every number after the first two is the sum of the two preceding ones. And the Fibonacci numbers have unique properties that make them useful in algorithm design, particularly in divide and conquer strategies. Awesome. So how does the Fibonacci search work? Right? Though first is that we find the smallest Fibonacci number greater than or equal to the length of the array. We then compare the target with the element at the current Fibonacci number index. And then we check if the element matches the target. And if it does, we return the index. And then if it doesn't, we then check if the target is less. And if it is, we narrow that range to the left and otherwise to the right. Then we essentially just repeat until the range is reduced to one element. Awesome. So what are some real world use cases for said search algorithm? Right, so we could use it in database indexing, and the Fibonacci search can be used to effectively search through database indices, especially when the data is uniformly distributed, right? And then we could also use it in large data sets, right? And we can use it to effectively search those sorted data sets where the distribution of data points is relatively even. It's also used in telecommunications, right? And it's useful in optimizing routing algorithms and searching through routing tables, right? It's also utilized in financial data, and it's applied in the searching through sorted financial data for specific entries like stock prices, transaction records, etc. It's also used in file systems, and it's can be used for searching through sorted file records to improve the file retrieval times. So let's go over the advantages and disadvantages of said search algorithm, right? So some advantages are its efficiency. It's very effective for large, uniformly distributed sorted arrays. And then there's a comparison reduction. So it reduces the number of comparisons needed compared to binary search in some scenarios. There's also order preservation, and it maintains the order of the original array, which can be beneficial in specific applications. And there's also the simplicity, right? So it's just a straightforward implementation using basic arithmetic operations and comparisons. So now let's go over some disadvantages. So some disadvantages is that the preprocessing overhead requires the computation of Fibonacci numbers up to the length of the array, which adds preprocessing time. It's also has a very limited use case, right? So it's not as universally applicable as binary search, best suited for uniformly distributed data. It's also less intuitive, so it's less commonly understood compared to binary search. And the memory usage, right? So the additional memory required to store Fibonacci numbers during that search process is a lot higher. So let's go over everything that we just learned, right? So it's very efficient for large arrays, Fibonacci search, and it also can be more efficient than binary search for some distributions. It also utilizes the properties of Fibonacci numbers to divide the search space, and it's best suited for uniformly distributed sorted arrays. It's also particularly useful when the cost of comparison is high. It also maintains the order of the original array, which can be an advantage in some applications. Another key point is that it's faster than the binary search in specific scenarios. And lastly, it reduces the number of comparisons needed. So in the next video, we will be implementing this Fibonacci search in the language Rust. So see you then.